I had kind of hoped to do a little bit of a more preparation this morning, but so this is a little bit fresh. Thanks
That's
so much.
quite all right. That's quite all right. Honesty is important.
So this is the so as Siobhan said, I'm a lecturer in TUS in mechanical and polymer engineering. This is a kind of a picture of the engineering building. I myself did my undergraduate in AIT or RTC as it was known at the time, and then I did a master's, and I did a PhD. So I've kind of I've been lecturing for about the last 23 years. So I'm going to give you an overview on the program. I suppose just I'll link in a little bit with the TUS vision. Describe what sustainable polymer technology means, and then I suppose give you a case study and show how it links in with the Run EU program, and then I suppose just discuss some of the skills that are involved in a PhD. And obviously, if you have any questions, you can ask me during the presentation or afterwards, whichever suits you all. So you can kind of see this is the TUS vision, and as you can see there, I've highlighted a little bit of student-centered, research-informed, industry relevant, and accessible to all. I suppose these are some of the kind of core aspects that I might talk about in terms of our PhD program. So you can kind of see for polymer technologies, what does that mean to a lot of people? And I suppose what I wanted to do is give you a kind of a flavor. When we think of polymers, we think of maybe commodity polymers, and you can see it's basically from the cradle to the grave. But there's also a lot of expertise in medical device, and industry in Ireland is extensively involved in polymers. So I want to give you a flavor of some of the PhDs that's going on, and then I suppose tie that in with how we can kind of look at sustainable polymer technologies from a PhD program perspective. So as I said, the Irish polymer industry is enormous, and it creates a lot of jobs, indigenous jobs. It also creates a lot of direct investment and exports. So, and it's right across the sector, injection molding and raw materials and suppliers. So what we're traditionally, so when I would have started, I would have graduated in 1994. And it would have been more low cost and high volume. In other words, you would have injected and molded a lot of kind of components. And that's where you would have got the kind of the general perception it was cheap. Cheap polymers would have been cheap. But now it's kind of going on to more high value products. That high value products requires very highly skilled workforce. You're talking about obviously honors degrees and masters and PhD, because the technology, the materials is very advanced. So I suppose what I want to do is I'll talk about the PhD program from a sustainable point of view. I also want to basically talk a little bit about our ongoing research and in terms of the lectures, different areas that I'm involved in, and I suppose show some of the PhDs that I'm involved with. Now, obviously, I'm looking at my own kind of little section, and there's my colleagues like Declan Devine and Sean Lyons and Noel and Apt and Margaret are doing a huge amount of research, and Luke Geaver as well, research as well. So what I want to do is kind of from a personal point of view, just show some of the areas that I'm involved in and how they can be applicable to polymers and sustainability. So we have Borshin here. She would have finished her PhD And you can kind of see there's a lot of nanotechnology here, and propolis. So you can see, everybody can see the screen. You can see the screen, all right, Siobhan? Yeah. Okay, perfect. So propolis would be a natural product that would be used for bees, and it has antimicrobial and antibacterial properties. So Borshim would have finished her PhD. I would have been her supervisor here. But ongoing, we have Jefferson. Jefferson is just finishing his PhD as well at the moment, and he's working in Abbott's. And what we're doing there is we're looking at different polymers, or polymer drug carrying systems for treatment of tumors. Vivi is doing her PhD at the moment as well, and she's using natural products, and these are chalcones. And you can kind of see just here in the corner of the screen here some of the different types of applications they can be used in. So, and Lynn is also I'll just clear the drones. Lynn is also involved in, I'm supervising Lynn, and she's looking at drug delivery for the brain. Okay, I suppose you're wondering how this is relevant to polymers and sustainability. But what I'm doing is, I suppose some of these skills are applicable across the board. But we'll go into a more detailed example in a few minutes. Keane is also working on these hydrogels that are smart. So in other words, what you do with these is you apply a simulation, and what will happen then is it acts more or less like a muscle. So in other words, it can contract and expand, and they're useful from the perspective of different applications. And I suppose what I'm involved in, a lot of it is collaboration. So this is with the Atlantic Technological University, and Nimra is doing a lot of modeling on machines as well. Okay, she's doing her PhD on extrusion. So in terms of sustainable polymer technologies, so that was a flavor of some of the PhDs I'm involved in, and I'll give you a case study in a few minutes and go into a little bit more depth about what we can do and the skills that are required. So when we think of polymers, unfortunately, polymers have a bad reputation, and it's in certain applications or certain circumstances, it's well deserved. So how can we kind of look at a program that will address some of the kind of environmental issues or make the polymer technology more sustainable? So if we looked at the EPA report, we produce, this is for Ireland, we produce 225 kg of waste per person. So, and a lot of that we can kind of see there's 62 kg of plastic there, and 62% of this was recycled. But I suppose when we're looking at the circular economy and reusing it and addressing how we can kind of, and sometimes recycling isn't, putting something into a recycling bin isn't necessarily recycling it as well. So we want to examine different areas that we can kind of add value to this. And from the perspective of the future skills, future jobs, there is a focus on sustainability, energy efficiency, and renewable energy. Okay, and one area that I'll just talk a little bit more detail about is the bioeconomy, which aims to maximize renewable biological resources. Okay, so from the perspective, there's a lot of skills involved in a PhD. There's a lot of kind of technologies, and from a sustainability point of view, there is obviously a need. And it's something that Future Jobs 2019 has this is a government report, has talked a little bit about. So how we can kind of do this is there's all right, some areas we may look at different applications. So I know we're focusing in on industry here as well, and I've been talking to Siobhan about different avenues that we can kind of look at from the PhD perspective. There's different, obviously there's biodegradable green polymers, and there's recycling methodologies, and I know some of my colleagues, as I mentioned already, are involved in a lot of these areas. Okay, so there's from a sustainability, these would be the kind of the core kind of areas that we could kind of look at. So in other words, materials and technology and expertise. So I'm just going to just spend a few minutes talking about one of the case studies that I'm involved in, and show how we can kind of link with some of our partners in their own EU consortium. So we have so as well as skills in TUS and based in Athlone and obviously in Limerick. We've a lot of collaborations. So one of the collaborations that we're looking at is, or I'm involved in, is with Gabriel. And Gabriel did his PhD in TUS, and now he's presently working in Brazil. So what they have a lot of experience about these novel products from Brazilian native flora and fauna. And Chelly, who also worked over in Brazil, is presently doing her PhD in TUS under my supervision. And one area that we looked at is these rhododendrons. Okay, so if you look at rhododendrons, are an invasive shrub, and they're not particularly good for the environment. They outcompete native plants, so we want to get rid of them. Okay, now and from our perspective, we thought, well, let's have a look at, instead of just getting rid of them, let's see if we can find a use for them. Now, from the perspective of using them as well, it's not just, this can be kind of applicable to different plants as well. So what we wanted to do is look at the leaves, the stems, and the flowers as well. You can kind of see the little extruder that's running there in the corner, and what we're doing there is we're making microcellulose. So cellulose is a type of plastic basically from plants. So this is applicable to not just for rhododendrons, but different. It's kind of like a case study. So so this is a sustainable polymer technology. Now, what we're doing here is, I'm kind of just show you a graphic of how we can get this micro or cellulose from a plant. So what we're doing is maybe looking for novel products from natural resources. Now, what was really interesting from our perspective was we talked to both Lyra and Hank for their kind of expertise. So Chelly went over to she's gone over both to Portugal and to Finland. And from the perspective of, you can see here on the right hand side, this was a scaffolding. So it's a 3D printed scaffolding using our microcellulose. And that was an interesting kind of application for us. So we can combine it with different materials. On the left hand side here, Chelly is looking at extractions. So from our perspective, we can get microcellulose, but we're not really familiar with what kind of extracts can be taken from the rhododendron. So for argument's sake, there's this thing called mad honey. So bees can make honey from rhododendron flowers, and that results in bears can eat it for argument's sake, and then they basically go mad, right? So it's a psychedelic extract. So we're not really familiar with that kind of applications. So what we wanted to do was talk to Pauli in Finland, and they're looking at extracting these different materials from the flowers. So that gave us an extra kind of understanding that we didn't have at the moment, right? So as well as that, rather than having a two-way street where we kind of go over there and we look at extracts from the different rhododendrons, we also said, well, let's kind of see what we can do in TUS. So Harvey gave me some natural indigo. So what we did was we put some natural indigo in polypropylene. We injected and molded it. Okay, so you can see these are injection molded. So what we have there is a tensile bar and an impact. So in other words, we can look at the mechanical properties of it. Okay, so from our perspective, what was quite interesting was when you can see here on the left hand side and the right hand side, you've got so the indigo is a nice color. It's a nice kind of a blue color, right? And you can see it here on the right hand side, and that's turned slightly pink. Okay, now, and that's reversible, and that changes color with different temperatures. Okay, so it's a thermochromatic material, and that's something that Finland hadn't really kind of thought about much, and from a polypropylene point of view, it's quite an interesting property, and we basically we picked that up when we were doing our investigation. So as well as, I suppose, doing so Chelly's gone over there. She's looked at kind of collaborations from the perspective of different technologies. But Chelly's also kind of done these short advanced programs. And I suppose from the perspective, the TUS has delegated authority to level 10. So we can award PhDs. And part of the awarding is there's elective modules. And this would be kind of an example of maybe something we could kind of incorporate into our elective or mandatory modules where you do some of these short advanced programs, and this is for circular design with plastics. I don't know how am I doing for time, Siobhan?
About 2 minutes would be great, Michael. There's loads to take in, so I don't want to finish you up early, but
not so. No. It's so I suppose I'll skim through this in terms of PhD skills, and I won't go into in total in depth. But what we want to do is systematic acquisition, understanding of a substantial body of knowledge. Okay, and you have to have a range of skills. All right, and this is from the module manager in TUS, and that's for a PhD, and some of the learning outcomes that we would kind of highlight. And scrutinize and reflect on social norms. So I suppose what we're doing is, from a sustainable point of view, we've got there's an input from the government, there's an input from society as well, and I suppose it's to try and tie these things in. So I'm conscious that this conference is about industry as well. So it's not just about, from our perspective, just talking about academia. It's important that we also tie in these applications and this technology with different kind of companies as well. So in other words, the entire package is, from a perspective of a PhD program, it's obviously we've publications and journal excellence. We've got our research interests, and then our collaboration with Run EU or different, or Brazil, and then also external from the perspective of different companies as well, so that they have a buy-in. And Siobhan and myself and Paddy have been having a number of discussions in terms of funding as well. So it's important to kind of, I suppose, to get buy-in from industry as well. Okay, thank you very much, and I'm delighted to take any questions.
Michael, thanks very much. The message that I'm getting from